Okay. So easing you back into the semester, with some practice doing wacky data access. So if you navigate to B courses, the materials for this assignment or for this class will be under discussions and then FITS discussion. FITS is a file type that is very commonly grabbed from telescopes. They can store huge amounts of data based on the way they're encoded, I believe. FITS stands for something that I can never remember. So actually, let's see what it is. What does FITS stand for? Flexible image transport system. Yeah, so that file that you guys used to plot the pillars of creation, that was a FITS file. You had some built-in code to access it and plot it. But now I'm asking you to, from scratch, access and plot the file that I have given you guys, which is here, FITS file discussion.fits. Actually, really quick, some announcements. For everyone who got their final proposal in, we are working on getting you guys feedback. Some of you have comments on your submission, some of you do not. Hopefully by the end of the week, everyone will have comments on their submissions. For everyone who talked to me about doing an animation for their project, I don't know if you guys saw my ed announcement. I made a quick video walkthrough of how to do it. You're welcome to just kind of try it. It's fun, it's interesting, and it's really useful. The one that I did is animationdemo.ipynb. The one that a few of the previous instructors made with a different function is under animation guide, so don't get those mixed up. The YouTube video is on our homepage, our YouTube channel, which you all have access to, and the video itself is linked in the announcement. Yeah, cool. Any quick questions about final projects now? Cool. Okay, let's actually jump into what we are doing today. So, I hesitate to say that this is going to be a hands-off class for me because it's not. I will be helping you, but it's going to be a bit of a struggle session. In the nicest possible way. I'm gonna have you guys spend about 10 minutes looking over this, getting the file downloaded. I will make sure this stuff goes up by the end of the week. But I do want you guys to just struggle a little bit with figuring out a new, slightly weird file format, because they're funky, they're fresh, and I'd rather you learn how to do it here than at your first job. So yeah, go forth, and I will not be answering questions about the assignment or about how to do the assignment for the first 10 minutes. But I will be helping you guys with any like computer problems that you have. So just feel free to raise your hand. But yeah. Go forth, review instructions. It's basically get the data out of the file that I give you and plot it. It sounds simpler than it is. Okay. Now I did tell you to try to open it without Python. Can someone tell me what happened? Don't overcomplicate it. If you tried to open it by just clicking on the file, what happened? Yep. Or you get an error, or you just get nothing. FITS files are super complicated. If your computer could parse them by themselves, then they would take up way too much memory. We're talking about like so much data, like telescopes pull so much data. FITS files compress that and make it really easy to transfer them. And so if you're working with raw telescope data, it's really important to be able to work with complicated file formats. So FITS files, you can't just click them and open them. Yeah. Did anyone get to looking at a way to open these files? Can people share? Yeah, go ahead.
It's not open and then file name.
Yeah, great. So and you found that on our nifty little link. There was a question mark at the end of that.
Oh, yes.
Sorry, that's very much. So let's get Jupyter Notebooks open. One good reason to use Jupyter Notebook for something like this is that you can kind of do like if you have an issue, you can just go back into your old, oh no. No. Holy crap. Okay. Cool. So it is in there. Let's go here. Let's go move it in here. This is me being lazy. Okay. New Python 3. Great. Fits discussion. Okay. So what did you have to import for that? What's the import statement?
It's astropy.io, right?
So import
Astropy.
astropy import fits like this. Great. Cool, that ran. That worked. That's so exciting. I love it when things work first time. So, and then you said fits.open. And then my file name, where did I put you? Rename, I'm gonna call it copy, rename. Cool. What else did you do from here?
Well, I guess I read that.
Okay. Do I need to set it to a variable? Do I need to, is there something else? Okay. Let's call it fit. Is this, then fit.info. Nice. That is, did anyone else get to this point? Great. Awesome. Yeah, I see some shaking heads. That's good. So yeah, these are some weird things. So fit. Okay. AstroPy, I think we've briefly touched on AstroPy before. IO means input output. It's short for input output. So it makes sense that our fast image or flexible image transfer system would be there. And it makes sense that the fast image transfer system would be in AstroPy because we deal with massive amounts of data. Yeah, so fit equals fits.open. That's relatively normal. You guys have seen the open function, I think. It's okay if you haven't. Did anyone else get anywhere else? Or I guess shout at me the issues you were running into. And we'll talk through them. Yeah.
Why can't you use the file?
Like if you click on it?
I guess I was
Like if we do this,
No, not that, but like in Jupyter Notebook,
huh?
once you open, why can't you see it?
So if you call fit like that, why can't you see it?
Okay, I did get that.
Yeah.
Okay.
So we're gonna do order or object-oriented programming pretty soon, but this is a good indication that you are working with objects. Python recognizes these things called objects and it operates on them. We'll talk about that a little bit more. You don't really need to understand all the way about this. But so if you see this, you'll see fits HDU image primary HDU object at that's a bit string, and then fits HDU table bin table HDU object at bit string. Yeah.
That's how you everything that the info does, but weirder.
So info parses what's in there. So the only thing that this tells you is that you're looking at a primary HDU and a bin table HDU. But info tells you what this is called, tells you that it's a primary HDU, tells you the version, oh my God. It tells you the cards. I don't really recall what the cards are. It tells you the dimensions, and it tells you the format. There are ways to look at what those format symbols mean. Highly, highly, highly recommend looking into it. Yeah, so another thing I would like to show you is just a syntax thing, just to make this slightly easier. If you are doing it like this, and you call fit.info, and then you say and you have to close the fits file. So you have to call fit.close, because otherwise it's living in your computer memory, and it's a massive file. You guys see how many rows there are? That is so many. It's actually not that many in the grand scheme of things, but you do have to close the fit file. So in order to not have to type that extra line, because we are all very busy people, if you do with fits.opened and then your file name as fit, it'll give you, this is a really fast way of opening things, and then you can call fit.info inside of this block of code, and it gives it to you, and now, well, the fit is closed. It still knows what fit is, but yeah. So play around more with that. Yeah. Yeah, play around some more with that. Oh, also one last thing. The primary HDU doesn't have anything in it. It's just fits files require you to have a primary HDU. It's a formatting thing, and it makes it so you don't break things. And no one likes when you break things. Computer scientists are very against that sort of thing. So there's nothing in the primary HDU. Focus on the bin table HDU. Think about how to get at that bin table HDU. An HDU is just an object that these fits files are made up of. So yeah, go forth. Again, give you another 10 minutes to work through this. If you call me over, I might be a little more helpful. Also recording. Any ideas? Yeah, you're just trying to access the data. Is there a process that you've been trying, that you've been using, errors you've been running into? That's an interesting one. I don't think I've ever seen that one. So one thing that I've seen is this kind of indexing through the HDU objects. Raise your hands if you've run across this indexing. Awesome sauce. And by indexing, I just mean if you said as fit, then fit not or fit one. Cool. Another thing I'm seeing pop up is this dot data. How many people have run across that? Yep. You made it work? Fair. What error are you getting?
I think I'm also getting the IO operation of the file. Yeah.
Yeah, so the thing about using this is that when you open this file as fit closes. So if you want to get data, then you need data equals fit. And then what goes in the brackets, Claire?
1.
Mm-hmm. And then dot data. Cool.
But you need to do that in it?
You need to do it while fit is not closed. Because you close fit. And once fit gets closed, you don't have access to anything inside of it. But if you call dot data on it, what are someone does anyone have an idea am I gonna have an iLock operation issue when I run this? Or an IO input output on closed file error? Did you just run it, Claire?
Yeah.
Whoa, I like that. Okay, that's funky. It's also really hard to work with. So did anyone get further than this? Getting at the data, yeah. WCS, okay. How do you use it? From astropy.wcs import WCS. This. Cool. Okay. Fit one dot header. Okay. Just run that. Cool. No errors. We like that. So what happens when we call it? Okay. That's great, actually. Because we know that it's a two-dimensional array. We have wavelengths. Actually, we didn't know that. I'm telling you that now. We have wavelengths as one column, and we have flux as another column. So that's by definition two-dimensional array. That's good. It says we have two WCS axes. I forget what WCS stands for. Do you have it pulled up? Yeah, what does WCS stand for? Okay. Warehouse control system? No. AstroPy. World coordinate system. Okay. Yeah, I mean, yes. I wonder what happens if we call WCS on data. It gives us an error. Rec array has no attribute keys. Yeah, that's because I made it and I didn't make it well. One dot header. I think because I didn't give it any WCS keys, you won't be able to access it like this. It's gonna just give you the error. Did you manage, before I put my foot in my mouth, did you manage to put, what's it called? Did you manage to get the data out of this? Okay. My instinct is that because I mean, I've never used the WCS package, I think I tried when I first started looking into this, but it got complicated really fast. And I think I spent a month just not doing it. So, I moved on. So I can't, unfortunately, help with WCS. But I can say, so we have this data. Let's actually open up the FITS file handling. Cool. Most people got here. That's good. We got here with the .info. After you're done with the open file, close it. Working with large files. Feel free to interrupt me right now. I'm just kind of scrolling through documentation. Cool. Okay, so this is a great. This is where we've got to, except we didn't do the dot verify. That's fine. Let's see what happens when we call header on it. On fits.info. So we're just gonna say HDR equals fit1.header. And we're gonna print header HDR. Okay. So that gives us kind of an idea of what we're looking for. We know that n-axis 2 has the actual data and n-axis 1 has something weird. I'm not sure why it has 8. But I do know that 31023, that's the number of data points I created. And I know that there's 2 columns. And it calls it the number of table fields. So that's weird. We haven't really run across fields. So one great thing to always keep in mind is that when you see a word that you aren't sure if like you haven't seen really before, it might be a keyword for, it might be an aspect of the file format you're trying to open. So if I say data.field. Okay, well, it didn't give me an error, so it's a thing. One thing you can do, this is a really great thing, is if you put 2 question marks behind it, it gives you a full, cool. It gives you a full documentation of the thing. So it says def field, self key. We'll talk about what self is, but this is the interesting one, key. Key is really quite interesting because that is, let me see. Self dot columns of key. Okay. So we see that key is being used as an insect or as an index. So let's actually call dot columns on this. Oh, okay. That's interesting. I wonder if this, never actually done it this way. Okay. Data.columns flux. Okay, that didn't give me exactly what I wanted. That's okay. Let's see if we do it with, okay, cool. Data.field. Okay. I guess let's see what happens when we call data.field of flux. That's interesting. Has anyone gotten to this point? Yeah.
Why are you calling it flux?
Because that is the title of something that we saw. So if we call print header I think. Print HDR. Yeah, one of the names is flux, which means flux is one of the numbers that we are getting at. So here we have an array. That's great news. Can anyone tell me why that's great news? It's okay if you can't. I'll just tell you. I like saying why things are great news. Makes me happy. Yeah. Yes, we know how to plot an array. We don't know how to plot a stupid rec thing. It's called data. What is a Fitz rec? I don't know. I really don't. I could not explain to you. I think it's a record array, but I could not explain to you what that actually means. So I like data.field. Data.field is good. See what happens when we do this. Cool. So if we go back to this file here, if you're looking here, we see that my plot starts that probably starts at around 500, which you can tell by the axis ticks. It's on a scale of like tens of thousands. That is wavelength in angstroms. Starts about 500. That's really great because then we can say, oh, this starts at 500 too. So I know that this is my wavelength, and we can corroborate that by saying, by copying this. No, don't do that. And saying that. Cool. That's our wavelength in angstroms. You have that array now. You know how to plot two arrays against each other. Cool. Questions? We are nearing the end of the time, so I will be putting this up at the end of the week. Being a bit of an idealist about this, I know you guys have a lot on your plates, but I would love it if you guys could try to replicate this and actually get the plot outside of class, but I know that's not necessarily going to happen. So if you want to just wait and see at the end of the week, or if its files don't really matter to you for your final project, or like in the short term, that's fine. You will have this as a guide if you ever run into them in the future. Go forth. Have a wonderful day at school. And let me know if you have any questions.